You know, we've all talked to chatbots, but what's the next big step? Today, we're diving deep into the architecture for apps that don't just chat with you, they actually do things. We're talking about a leap from just answering questions to autonomously getting work done.
So here's our game plan. First, we'll nail down what a real application agent is. Then, we'll tackle the huge question every developer is asking. We'll look at why the easy approaches just don't cut it, and then we'll unpack a much smarter architecture. We'll even see it in action and wrap up by looking at what this all means for the future of software.
All right, first up, what does it really mean to make an application agentic? You hear that buzzword everywhere, right? But it's not just a new coat of paint or a slightly better interface. It's a fundamental upgrade to what our software can do.
And this quote just hits the nail on the head. Building a real agent isn't about slapping a chatbot mouth on your existing API. No way. It's about embedding complex reasoning and the ability to act on its own deep within the application's core.
Here's the difference in a nutshell. A simple chatbot, it's like a helpful librarian. It can go find information you ask for. An application agent, though, that's more like an expert assistant. It understands your goal, it makes decisions, and it actually goes and does the thing for you.
So, making that massive leap in capability, well, it leads us straight to the central problem. This is the challenge that some of the smartest people in technology are wrestling with right now.
And here it is. This is the billion-dollar question. How do you safely and effectively connect a powerful AI brain to the complex, specific, and, let's be honest, often messy guts of a real-world application? Trust me, it is much, much harder than it sounds.
Now, before we get to a solution that actually works, I think it's really important to understand why the most obvious approaches, the ones you might try first, so often just fall flat on their face when they meet real-world complexity.
So developers have a few tools in their toolbox, right? You can try to jam everything into a giant prompt, you can use what's called tool or function calling, or you can build a RAG system. That's where the AI retrieves some info before it answers. But here's the problem. If you use these in a simple, straight line, they become incredibly brittle.
And this is exactly why those linear approaches fail. When your agent's process is just one single straight shot, you hit a brick wall. You end up having to write new code for every little task. The agent has no idea what data you even have, and it completely breaks down on any request that needs more than one step to figure out.
So what's the answer? The solution is to stop thinking about the agent as one single all-knowing brain. Instead, we need to architect it like a coordinated team of specialists, where every single component has one very specific job to do.
Let's meet the first member of the team, the intent resolver. Think of this component as the translator. Its only job is to look at what you typed and figure out your main goal, your intent, and then pull out all the key pieces of info, the entities.
Next up is the schema mapper, our team's librarian. This guy is a total expert on your app's data. It knows that when a user says something casual like pressure, what they actually mean is the super specific database field Opera Max Press Value. It's a total data nerd.
And now for the lawyer. The query builder takes the structured goal from the translator and the precise field names from the librarian, and it drafts a perfect, safe API query. This is so critical because it stops the AI from just making up its own, potentially dangerous requests.
For the really complicated jobs, you need a project manager. That's the sequential executor. This component knows that some answers can't be found in just one step, so it runs a series of API calls, one after another, using the results from the first to inform the second, building up all the context it needs.
And finally, you've got the spokesperson, the response synthesizer. After all the other components have done their job, it takes all that raw technical data and crafts it into a clear, helpful, human-readable answer for the user. It might even suggest what to do next.
Okay, talking about these components in theory is one thing, but now let's see how this team of specialists actually gets to work and solves a real-world problem together. This is where it gets fun.
All right, so picture this. We're inside a complex industrial app. An engineer asks what seems like a simple question. Show high-pressure pipes near FT 3100. Now, a simple agent would probably just choke on this, but our team of specialists, it's built for exactly this kind of thing.
So let's follow the ball. First, the intent resolver gets it. Okay, the goal is to find something nearby. Then, the schema mapper translates pressure into the right database field. The query builder is smart enough to see this is a two-step problem. First, find the location of FT3100, then find pipes near it. The executor runs those two queries in order, and finally, the synthesizer gives the engineer a clean, simple list. Done.
And this diagram just lays it all out beautifully. You can see the user's question coming in at the top, just plain English, and then it flows down through each specialist. Each component adds a layer of structure and precision before handing it off to the next. It's like an assembly line for understanding, which results in a safe, structured answer at the end.
Okay, reading data is cool. But what about writing data? You know, actually making changes? A truly autonomous agent has to be able to do that. And let me tell you, that raises the stakes. Big time. You have to be so much more careful.
And this architecture handles that with a completely separate write pipeline. You can see it at the bottom. Before any action is taken, the request has to pass through an action router and, this is the most important part, a write validator. You can think of this as a final critical safety check, making sure any change is valid and allowed before it ever gets executed.
All right, so let's zoom out. What does this big architectural shift really mean for how we're going to build and use software from now on?
It really boils down to these 4 key ideas. If you're going to build a robust agent, you have to decouple it into a team of specialists. You have to bridge that huge gap between how humans talk and how computers store data. You absolutely must build in safety with structured queries, not just letting the AI run wild. And you need a way to orchestrate complex multi-step thinking.
And this brings us to one last really big question. This kind of architecture, it's not just a new feature, it's a totally new way of interacting with technology. We're moving away from clicking buttons and directly manipulating software to just delegating outcomes to these autonomous agents. So when every single app has a powerful agent inside it, how is that going to fundamentally change the way we all work?